Alright, they want us to solve this problem right here by using matrices. So the first thing we're going to do is we're going to set up a matrix equation that is the exact same as that system of equations. And the way we do that is we first take out the coefficients in front of the x and the y. So there are those coefficients. That's called the coefficient matrix. Then we write x, y, that's your variable matrix. And then we write your solution matrix. You'll notice that if I take these right now and if I multiply these matrices together, remember multiplying the matrix would consist of multiplying the rows by the columns. I would get 2 times x plus 5 times y equals -4, which is that first equation right there. So you can see that this is the exact same system of equations. This equation this matrix equation I have right here is the same system of equations. Now what I want to do is I want to solve this system of equations by taking the equation or the matrix and solving it algebraically. Now I'm not allowed to divide. If I wanted to get x, y by itself, ideally I would divide both sides by that. Well, there's no such thing as dividing in matrices, but there are inverses. And so instead of dividing by that matrix, I can multiply by the inverse matrix. So first of all, let's call this matrix A, and let's find what matrix A inverse looks like. And there's a rule for that. You take the discriminant, 1 over the discriminant, which is 2 times -1 minus 3 times 5. So it's -2 minus 15, which is -17. That's your discriminant. And then you take these inside things and you flip the first and the fourth and you change the signs of the two other ones. That's my inverse matrix. Now what I want to do is I want to think about this equation. It would be A times x equals B. I want to take A inverse. I'm dividing by A to get x by itself. Take A inverse and multiply it by B. That's what I'm looking to do. So let's just leave it as -1 over 17 times -1, -3, -5, 2 times -4, 11. Now notice I didn't distribute in this -1/17. I didn't distribute that in. I could have done that, but distributing it in would have just given me fractions that I'd have to deal with them the entire time. Instead, I'm going to multiply these two things first. Multiply this times this, and then multiply this times this, and I'll get my new matrix. I'll write that over here. I'm going to get -1 times -4, that's +4, minus 55, so that's a -51, and I'm going to get +12 plus 22. 12 plus 22 is 34. There's my matrix. Now don't forget I still have the -1 over 17 on the outside of that. So I'm going to distribute that in. This is matrix multiplication or scalar multiplication, so I actually just multiply the negative into both of those, or in other words I'm dividing by -17. And conveniently I get both of those numbers are divisible by 17. I get +3 for x and I get -2 for y. So those are my answers. X comma y, or xy equals +3, -2. So x is 3, y is -2, and you can of course check those by plugging them in. 3, -2, 3 times 2 is 6, minus 10 is -6. Plug it into the bottom one. 3, -2. 3 times 3 is 9, minus a -2 is +2, which is +11, and boom, it works. So that's how you solve a system of equations, by turning them into matrices and solving your matrix equation.